Good morning everyone. Today we are going to start a physics basics course. On week 1 we are going to study about introduction to physics. The table of contents. The table of contents contains basically three things: introduction to physics, units and measurements, scalar and vector quantities. The learning objectives of the week 1 would be as following. The session will cover basic introduction to physics, units and measurements, deriving dimensional formula, scalar and vector quantities, addition and subtraction of vectors. Let's get started from introduction to physics. What is physics? Physics is understanding of nature and its laws. Physics identifies and reveals the fundamental laws that govern every event in nature. So, actually physics is the study of nature. Relation between physics and mathematics. Physics is basically based on mathematics only. Or we can say that mathematics is the language of physics. Defining and explaining the laws of nature or physics without mathematics is really challenging, or we can say almost impossible. Moving to the next slide. Physics is basically categorized into two levels. This has been done based on particle size and moving velocity. The categorization of physics has been named on classical physics and quantum physics. If the particle size is more than 10⁻⁻⁶ meters and the speed of the particle or the moving velocity of the particle is less than 10⁸ meter per second, then it comes under the classical physics category. Similarly, in the case particle size is less than 10⁻⁻⁶ meter and the moving velocity of the particle is greater than 10⁸ meter per second, then it comes under the category of quantum physics. The next thing we are going to study here today is units and measurements. Defining units. Units can be defined as a measure of quantity. It is a measuring standard of similar quantities. Like here we see an elephant and a cat. Both can be compared based on their weight. But do we know that how many times the weight of the elephant is higher than the weight of the cat? We don't, because we don't have the units. So suppose there is a unit mass of for reference. Then we can say that an elephant and a cat can be compared for this purpose. Suppose the weight of the elephant is 200 times of the unit mass. Also, the weight of the cat is 2 times of the unit mass. Thus, we can compare both and say the weight of the elephant is actually 100 times more than the weight of the cat. Units are defined by the General Conference of Weight and Measures, adopted by the International System of Units, that is SI unit. This has been done on an international agreement and it has been finalized on 1971. Basically, there are two types of units: fundamental units and derived units. Further, we are going to elaborate this. The fundamental units or base units. These units measure the fundamental quantities. Example, distance, temperature, time, etc. The fundamental quantities, they are dependent from one another. Let's revise all this. Fundamental units used to measure the fundamental quantities. And what are fundamental quantities? Fundamental quantities are independent from each other. Further, we are going to study about properties of fundamental units. The fundamental units basically should have two properties. The first property is invariability and the second one is availability. Let's get to know what's invariability and what's availability. Invariability. The unit must be defined as such. They are never changing. They are never changing, actually, I must say. Further, the availability is defined as the units must be easily accessible for comparison with other quantities. Next slide. The second kind of units that we have studied is derived units. It is possible to derive all the physical quantities from base quantities or fundamental quantities. As all physical quantities can be derived from base quantities, base units can be derived from all physical units. Example: speed, force, work, etc. How we can say that speed is derived? We know that speed equal to distance upon time, where distance and time both are fundamental units. Similarly, force. Force is defined as the mass into acceleration. We are going to study in future slides. What is measurements? Compares how much a physical quantity deviates from the reference of basic quantity is called measurement. There are basically 7 fundamental quantities and their corresponding units that has been represented by symbols. The 7 fundamental quantities has been given in the table. The first one is length. The fundamental quantity is length. The fundamental unit of length is meter. The symbol of meter fundamental quantity length is m. The second fundamental quantity is mass. The fundamental unit of mass is kilogram. The kilogram is represented by the symbol kg. The third fundamental quantity is time. The fundamental unit of time is second. The symbol of second is S. The fourth fundamental quantity is electric current. The fundamental unit of electric current is ampere. The symbol of ampere is capital A. The fifth fundamental quantity is thermodynamic temperature. The fundamental unit of thermodynamic temperature is Kelvin. Kelvin is represented by the symbol capital K. The sixth fundamental quantity is amount of substance. The fundamental unit of amount of substance is mole, and it has been represented by the symbol MOL, mole. The seventh and the last fundamental quantity is luminous intensity. The fundamental unit of luminous intensity is candela and is represented by the symbol CD. There are 2 supplementary units also included in the previous fundamental units. Those are plane angle and solid angle. The fundamental quantity plane angle as its fundamental unit is radian. The symbol of radian is RAD. The fundamental quantity solid angle has fundamental unit steradian and has been represented by symbol SR. There are also SI prefixes. Let's get to know them. What are SI prefixes? The physical quantities vary greatly in terms of their magnitude. Example, the mass of the earth is 6 into 10 power 24 kg. Similarly, if we talk about the mass of the electron, it's 9.1 into 10 power minus 31 kg. So, as I have told that the quantities vary greatly. The mass of the earth is 10 to the power 24 and mass of the electron is in terms of 10 power minus 31. So there is a very huge difference. Based on that, CGPM suggests representing the quantities in the power of 10. Let's see how it suggests. This is a table provided by the CGPM, and as I have told you, they have decided to fix it in the power of 10. Suppose 10 power 1 can be said as deca and represented by the symbol DA. Similarly, 10 power 2 has been represented by the symbol H and called as hecto. 10 power 3 is kilo and represented by the symbol K. 10 power 6 has been represented by the symbol capital M and called as mega. 10 power 9 is giga, represented by G. 10 power 12 is tera, represented by capital T. 10 power 15 represented by capital P and called as peta. 10 power 18 is exa and represented by symbol capital E. What's 10 power minus 1? 10 power minus 1 is deci, represented by symbol D. 10 power minus 2 is centi and represented by symbol C. 10 power minus 3 is milli and represented by symbol M. 10 power minus 6, it is called as micro, represented by symbol mu. 10 power minus 9, it's called as nano, represented by symbol N. 10 power minus 12. It's called as pico and represented by symbol P. 10 power minus 15. It's called as femto, represented by symbol F. 10 power minus 18, called as atto. It's represented by symbol A. So, exa, peta, tera, giga, mega, kilo, hecto, deca, deci, centis. These are all the prefixes. And E, P, T, G, M, K. These are respectively their symbols. Further, we are going to study about dimension. Quantities that are derived from base quantities are expressed as a product of different powers of base quantities. Like, for convenience, base quantity are represented by a letter. Like, example of these base quantities representation is mass. It is represented by M. Length represented by L. Time represented by T. Electric current represented by I. Generally, these representations are in capital letters. Further, we are going to study formulating dimensions. Example 1. What is velocity? Velocity is equal to displacement upon time. So, the dimensional formula of speed would be, or dimensional formula of velocity would be Lt minus 1. Here, L is representing the displacement, T is representing the time. And since we see that time is in the denominator, so the power of time here is minus 1. For understanding in another way, let's get to another example. What is density? Density is mass upon volume. So, the dimensional formula of the density would be ml minus 3, since mass is represented by capital M and volume is represented by cube of length. But since we see that volume is in the denominator of the formula of density, therefore there will be power of minus 3 with the L. Thus, the final dimensional formula of density would be ml minus 3. Let's get into the third thing of our week 1 course. It is scalar and vector quantities. What are scalar quantities? The scalar quantity is one that has magnitude of the quantity and it must be added as per the algebraic rules. For example, mass is a scalar quantity, temperature is a scalar quantity. How we can say that mass is a scalar quantity? Okay, let us get into that. Let mass of an object is A and has been represented by Ma equal to 5 kg and mass of the object B is Mb, where Mb is equal to 4 kg. So, sum of both masses would be Ma plus Mb, that is 5 kg plus 4 kg equal to 9 kg. Since both the masses have been added as per the algebraic rules, therefore mass is a scalar quantity. Similarly, temperature is also a scalar quantity. Let temperature of body A is Ta equal to 288 Kelvin. Also, let temperature of body B be Tb equal to 310 Kelvin. So, sum of both the temperature is Ta plus Tb, where Ta was 288 Kelvin and Tb was 310 Kelvin, which sums up to 598 Kelvin. Since both Ta and Tb both have been added with the use of algebraic rules, therefore temperature is a scalar quantity. What are vector quantities? Vector quantity. It is a physical quantity which represents both magnitude as well as direction. It is added as per the triangle rule of vector addition. This is a totally different rule which has not been covered in the general maths as of the algebraic rule. Let's get to know what is vector quantity with an example. Consider a person traveling from home to park, then to a shopping mall. So the vector from home to park would be, let's say, HP, and from park to shopping mall, the vector would be PM. So the resultant displacement would be HM. Note, the point to be noted here is vector HM is not equal to vector HP and vector PM. As the figure represents the vector quantities here, they cannot be added as an algebraic rule. So we need to have a new rule for vector addition called as triangle rule of vector addition. the triangle rule of vector addition, it is also called as parallelogram law of vector addition. Let's get to understand what is parallelogram law of vector addition. Let there be two forces acting on an object A. Here is the object A in the figure. So the force 1 acts on A in a horizontal direction, causing vector A. Here the force 1 is acting on A in a horizontal direction, called as vector A. Similarly, the force 2 acts on A with an angle phi, they call as vector B. Force 2 acting on a point A, object A, with an angle phi. This has been named as vector B. To know the resultant force acting on object A is, we need to have a formula. Thus, the resultant force is represented as vector AD square is equals to vector AB plus vector B whole square plus vector DE square. Let's get to know where this is in the figures. Vector AD, the diagonal represents vector AD, and this is the resultant force. Vector AB is the force acting on the horizontal direction on object A. Vector B is here. Vector DE is here. So, getting back into the formulas, vector AD square can be written as A plus B cos phi whole square plus B sin phi whole square. Let's get into this. Vector AB can be written as vector A. Similarly, vector BE. Here is vector BE. If this is angle phi, this is also angle phi, and vector B, therefore, by using trigonometry, can be written as cos phi, B cos phi. Again, we need to going to understand this in a better way. AC is vector B. So, this is angle phi. So, this would be also angle phi. Therefore, by using trigonometry rules, we can say that vector BE is equal to B cos phi. Further, vector DE can be represented in the same manner. Considering triangle D, B and E and applying trigonometry rules, DE can be written as B sin phi. B is again vector DB. Phi is the angle between point DB and DE. Thus, DE would be represented by B sin phi. Again, getting back into the formulas, AD would be written as A square plus B square plus 2AB cos phi to the power under root. This is called as the resultant force. So, getting ahead, the angle of vector A is alpha, and where to find out angle of the resultant force, we need to find tan of alpha. That would be DE upon AE. Let's see this in figure. The angle of resultant force can be represented by vector DE upon vector AE. Using trigonometry laws, we can say that DE is B sin phi. AE is sum of AB plus BE. That is vector A plus B cos phi. That is what has been written here. So, tan alpha would be B sin phi upon A plus B cos phi. The next thing we are going to learn today is multiplication of vector with a constant. Let vector B equal to K into vector A, where vector B is general vector and it has been multiplied by the magnitude K. Thus, the magnitude of B is equals to Ka, that is mode of Ka, where K is constant, A is magnitude of vector A. So, we can say that if K is positive, vector B has same direction as of vector A. And if K is negative, vector B has the opposite direction as of vector A. The next thing we are going to study today is subtraction of vectors. Let there be two vectors, vector A and vector B. So, subtraction of two vectors can be done as vector A plus negative of vector B. Let's get to see in the figure. Let there be two vectors A and B. As I told, this is vector A, this is vector B, and negative of vector B would be in the opposite direction. So, this is vector minus B. Let angle between the vector A and vector minus B be phi. So, the resultant force would be vector A plus negative of vector B. We can see here as well. The resultant force would be a square plus b square plus 2ab cos phi to the power 1 by 2. Or we can say that under root of a square plus b square plus 2ab cos phi, where phi is the angle between the vector A and vector B, or negative of vector B. So what we have learned in today's session? The first thing we have learned is basic introduction to physics. What was the basic introduction? Physics is the study of laws of nature, and mathematics is the language of physics. What are units and what are measurements? What we have learned in units and measurements? Units are basically of two types: fundamental or base units or derived units, where fundamental units have the properties of invariability and availability, and derived units are being derived from fundamental units only. The next thing we have learned is deriving dimensional formulae. We have learned the dimensional formula of velocity is Lt minus 1. Further, we have studied differentiating between scalar and vector quantities. What are scalar quantities? Scalar quantities are the one which has magnitude only, like mass, temperature, and the scalar quantities can be added with general algebraic rules of maths. What are vector quantities? Vector quantities are the one which have both magnitude and direction, and the vector quantities have been added by triangle rule of vector addition, or it is also called as parallelogram law of vector addition. We have also studied multiplication of vectors and subtraction of vectors, where addition of vectors meant to be by the formula a square plus b square plus 2ab cos phi to the power 1 by 2, or under root of a square plus b square plus 2ab cos phi. This was the parallelogram law of vector addition.